Vectors in Calculus, Day 1. A vector is represented by a directed line segment. Vectors are equal if they have the same length and direction, in other words, the same slope. A here is the initial point, and B with the arrow is the terminal point. And we denote the vector with a little vector symbol, and then we go from initial point to terminal point. So this is vector AB. This is not vector BA. A vector is in standard position if the initial point is at the origin. In other words, we could have the exact same vector over here. And let's say this is the point negative 10, 3, and this is the point negative 2, how about 1? Then that means we're going in the horizontal direction. We're going 8 units. And then we would go from 3, that doesn't make any sense at all. So let's erase this. We'll restart this one. A vector is in standard position if the initial point is at the origin. Now let's say we had some vector over here that was the exact same vector. Let's say this point was negative 10, 1, and this point was negative 2, how about 7? That means the horizontal distance would be from this point from the initial to the terminal point would be 8 units, and then from 1 to 7 would be 6 units. So we could take this vector right here, put the initial point at 0, 0, and call this vector 8, 6, and these two vectors would be considered the same thing. Now these are not like less than or greater than signs, they're called chevrons. The component form of this vector is v1, v2 denoted with the chevrons. With parametric functions, our position is given by x of t and y of t. Position vector at time t is x of t, y of t, so this is position. The velocity vector is the derivative of the position, and the acceleration is the second derivative of the positions, just like we have seen all year. Example, a particle moves in the xy plane so that any time t, where t is greater than or equal to 0, the position of the particle is given by x is given by this function and y is given by this function. Find the velocity vector when t is equal to 1. So the velocity vector v of t is equal to the derivative of the x is 3t squared plus 8t, and the y component is 4t to the third minus 3t squared. And we're going to evaluate this when t is equal to 1. So the velocity vector when t is equal to 1 is, let's see, we have 3 plus 8, that's 11. And if we plug 1 in here, we get 4 minus 3 is 1. Find the acceleration vector when t is equal to 2. So now the acceleration vector is the derivative of the velocity. We have 6t plus 8, and we have 12t squared minus 6t. And we will evaluate that when t is equal to 2. So we have 12 plus 8, that's 20. And we have, let's see, 48 minus 12. I need 48 minus 12, that's 36. The magnitude or length of the vector is denoted with absolute value symbols, that means magnitude, and it's equal to the square root of v1 squared plus v2 squared, notice the Pythagorean theorem. And this is also the speed, so the magnitude of the vector and the speed of the vector is the exact same thing. A particle moves in the xy planes at any time t, where t is greater than or equal to 0. The position of the particle is given by x is this function, y is that function. Find the magnitude of the velocity vector when t is equal to 1. So we're looking at the velocity vector of t is equal to 2t plus 3, 3t squared minus 6t. Now we want the magnitude of this vector, which is the square root of 2t plus 3 squared plus 3t squared minus 6t squared. And we are evaluating this when t is equal to 1. We have the square root of, when we plug 1 in here, we get 5. 5 squared is 25. Plus, we get 3 minus 6 is negative 3. Negative 3 squared is 9. So we get the square root of 34. Another example, position of particles given by these two functions for x and y when t is greater than or equal to 0. Find the velocity and acceleration when t is equal to pi over 2. Alright, so we have the velocity is equal to negative 4 sine of t, comma, 2 cosine of t, and we're evaluating that when t is equal to pi over 2, which is equal to, let's see, we have the sine of pi over 2 is 1, so that's going to be negative 4, and the cosine of pi over 2 is 0. Then we have the acceleration vector is, let's see, we have negative 4 cosine of t, and we have negative 2 sine of t. And we'll evaluate that when t is equal to pi over 2, and that's equal to, see, cosine of pi over 2 is 0, so we have 0, comma. The sine of pi over 2 is 1, so we have negative 2. So there's the acceleration vector. B, what is the speed when t is equal to pi over 2? Speed is the magnitude of the velocity. So the speed is the square root of, here's the velocity right here, 16 plus 0, so that is equal to 4. Draw the path of the particle and show the velocity vector at t equals pi over 2. And show the velocity. Alright, so this right here is going to be an ellipse. We have x over 4 is equal to the cosine of t, and we have y over 2 is equal to the sine of t. So we can say that x squared over 16 plus y squared over 4 is equal to 1. So draw the path of the particle. All right, so now we have to draw the ellipse. The center is 0, 0, and we're going right and left 4. 1, 2, 3, 4. 1, 2, 3, 4. And we're going up and down 2 units. So up 2 units, down 2 units. So here is the ellipse, something like that. And we're supposed to draw the path of the particle. So we want to, so let's see where this actually starts. And we're starting at 0, when t is 0. So when t is 0, x is equal to cosine of 0 times 4, which is 4. And y is equal to 2 times the sine of 0, which is 0. So we have the point 4, 0 when this thing starts. So it starts right here. And let's say t is something nice. We have 4 times the cosine of pi over 2, let's say. That is going to be 0. And then y is equal to 2 sine of pi over 2, which is equal to 2. So we have 0, 2. So the path is like this. So we're going in a counterclockwise direction with this path right here. Now we're supposed to draw the path of the particle and show the velocity vector at pi over 2. Now we've already done that. We have the velocity vector at pi over 2, which is negative 4, 0. So we start where the particle is, where t is pi over 2 and where the particle is, and that's right here. That's right there. And then the velocity vector is negative 4, 0. So from this point we go over to negative 4, so we go left 4 and we go up and down 0. So here is the velocity vector right here, and what that shows is the particle's position and how fast it is going, the velocity.